Let's continue talking about the fabric device roles. In this case, we're going to talk about the control node. This control node performs the duties of a map server and a map resolver for the LIS protocol that we are running on the overlay. So we are going to put together these two roles into a single device, and we are going to call that device the control node. And the objective of this control node is to maintain a database that we are going to call the host tracking database. This database must be the same in all the control nodes that we have in our network. So in this case, we're showing two control nodes for high availability. And this host tracking database is made of mappings. So we're going to map endpoint IDs to router locators. So these databases that we'll have will include a lot of mappings, and the mappings of all the devices that I'm going to connect to my network, and all the prefixes coming from the data center, for instance. So what are examples of endpoint IDs? For instance, if I connect here a laptop that has the IP address 10.1.1.1, that could be an example of an endpoint ID. But if I connect here another device that has the IPv6 address of 2001, that could also be an endpoint ID. So this can be IPv4 addresses, IPv6 addresses. I can have, for instance, a wireless device that has a specific MAC address. And that MAC address can also be an endpoint ID. I can connect my fabric to an external data center, and I may receive prefixes through routing from that data center. I may be using, for instance, the whole network block 172.16.0.0/16, and that could also be an endpoint ID. So the endpoint ID can be IPv4 addresses, IPv6 addresses, summary prefixes coming from a data center, and the RLOCs. Remember that we are going to map extended endpoint IDs to router locators. The router locators will be actually the loopback 0 IP address that corresponds mainly to border nodes and edge nodes. And remember that I have a routing protocol running on the underlay that is storing all this information that comes from these devices in a global routing table. So I'm going to use the loopback IP addresses that correspond to edge nodes and border nodes that are advertised through a routing protocol in the underlay and placed into the global routing table to use them as the RLOCs. So the RLOCs come or must exist in the global routing table coming from the underlay. Now that we have explained where the endpoint IDs come and where the RLOCs are going to come from, let's examine how the host tracking database is built. When a device gets connected to an edge node, for instance, the edge node should notify of this device existence to the control nodes, and it's going to use a specific message in order to do so. It will have to notify all the control nodes in the network and it will use a map register message in order to do so. Then the control nodes will update their host tracking databases accordingly, and they will have to respond with a map notify message in order to let the edge node that the map register message was received successfully. So for instance, if I have this device that has the IP address 10.1.1.1 and this edge node has the loopback IP address 10.0.0.10, then the host tracking database on the both control nodes will be updated like this, with a new mapping for 10.1.1 mapped to 10.0.0.10. And if this border node is connected to a data center and this data center is using the block 172.16.0.0, and this border node has the loopback IP address 10.0.0.2, this border node will also have to register this prefix into the control nodes using a map register message, and the control nodes will have to respond with a map notify message. So the host tracking database will include 172.16.0.0/16 maps to the IP address that corresponds to the loopback 0 that exists in this border node, which will be 10.0.0.2. So that is how the host tracking database is built. Now let's put an example here. Let's imagine that the device that lives here wants to communicate with a device that lives in another edge node. This other device has the IP address 10.1.1.3 and exists in this other edge node that has the loopback IP address 10.0.0.13. So this edge node here will need to start setting up a VXLAN tunnel in order to send the packet that is destined to this device. But this edge node is unaware of where this device is connected in the network, so it will have to ask the control nodes. So in order to do that, it will send a map request message in order to ask where is 10.1.1.3 located in the network. And these nodes will have to answer with a map reply message, including the information to where this destination is located. In order to do so, they will have to query the database. The key in order to look up the database is the endpoint ID. So this edge node here will have to provide this information. It is asking where is 10.1.1.3. Then after performing a lookup in this database, in the host tracking database, the control node will be able to tell what is the RLOC that corresponds to this endpoint ID. And then it will notice the RLOC is 10.0.0.13. It will notify that using the map reply. Then this edge node will build a tunnel with a destination of 10.0.0.13 because the control nodes were able to provide that information. After doing these queries, these devices will use a cache. so they don't have to query again where the destination is located. After the cache is timeouts, these devices, the border nodes and the edge nodes, will have to query the control nodes again. But in order to reduce the amounts of queries, these devices, the edge nodes and the border nodes, will maintain a cache, which is usually 24 hours for Lisp. Now, how do we deploy the control node? We have several options here. We can choose the single deployment, where a single device is only running or performing the activities that correspond to the control node. So I have this piece of hardware that is only destined to be a control node. It runs in a specific device when it is a single deployment. And given it is running in a single device, it is recommended to be placed off path, like a DNS server does. So notice here that this device, this control node, is not forwarding traffic, and this means that it is off path. This is one way of doing it, connecting it to an intermediate node. But given we are using a specific device to be the control node, we can place it on another place in the network. And notice that we are showing two control nodes for high availability. So we can place them in a services block. So now my control nodes are separated from the fabric, and I am placing them in a services block in another part of the network. The other way to deploy the control node is using a co-located deployment. In this deployment, the control node coexists in the same device with and performing another role. For instance, in this example, these devices are being both border nodes and control nodes. So in this case, I cannot separate the control node into a single device and place it somewhere else in the network, because I am using the same device to run two roles. So in this case, we have a border node and a control node using the same hardware. Still, we are showing two control nodes for high availability. In cases where I am designing my network to allow guest traffic, I am going to use two more control nodes that are known as the guest control nodes. So I have two control nodes for my corporate traffic and two guest control nodes for my guest traffic, for a total of 4 control nodes. What is the hardware that I can use for a control node? If I want to use a single deployment, I can use routers. These are the routers that I can use. I can even go virtual with the CSR 1000V, so I can run my control node over a virtual machine. And remember to always take a look into the SD-Access compatibility list in order to have a more accurate and up-to-date list of hardware that you can use for these devices. That's it.